Hello students, hope you are enjoying the circles chapter until now. So let's continue with our end of chapter exercises, and we completed until the question number 13 from the end of chapter exercise, chapter 5, grade 9, Ganita Manjari. So this 14th question, the 14th question says, show that rectangle is the only parallelogram that can be inscribed in a circle. So I have drawn a circle with center O, and I have drawn a rectangle AB. Okay, I should name it C, and this is D. Okay, so basically this is a parallelogram. I should say that ABCD is a parallelogram, and we need to prove that this ABCD parallelogram is actually a rectangle. Okay, so now we know that this ABCD is a cyclic quadrilateral because it is inscribed in the circle. This is given, right, that it is inscribed in a circle. So this is a cyclic quadrilateral. So this means we know by the theorem 11, right, that the sum of opposite angles of a cyclic quadrilateral is 180 degrees. Okay, so by theorem 11, we can say that angle A plus angle C is equal to 180 degrees. Now, the property of a parallelogram, I should say here, ABCD is a cyclic quadrilateral and a parallelogram. Okay, so the property of parallelogram is that opposite angles of a parallelogram are equal, right? So this means that angle A will be equal to angle C. Now we have said angle A plus angle C is 180 degrees. So this means if we when we rewrite the first, this equation, this is 1. Okay, what just happened? Okay, I'll write it down. Okay, so we can say that rewriting 1, we can say angle A plus angle A is equal to 180 degrees because angle A is equal to angle C. So we have replaced angle C with angle A. Now this means 2 of angle A is equal to 180, or we can say angle A is equal to 180 by 2 is equal to 90 degrees. So we see here angle A is equal to angle C is equal to 90 degrees. And similarly, we can prove, we can prove the same thing for angle B and angle D. Angle B is equal to angle D is equal to 90 degrees. So all the 4 angles are 90 degrees for this quadrilateral or the parallelogram. So that is why, therefore, the parallelogram is a rectangle, right? So that is how we can prove it. So coming to question 15, show that if a rectangle is inscribed in a circle, then the point of intersection of its diagonals must lie at the center of the circle. So I have drawn a circle here, and I have drawn a rectangle A, B, C, D inside the circle. And the diagonals BD and AC, they are meeting at the point O, right? So what we need to prove here is that O is the center of the circle because it is the intersection of the two diagonals. So let's write it down. ABCD is a rectangle and it is a cyclic quadrilateral because it is inscribed inside a circle. So what this means is, because it is a rectangle, my angle D will be equal to 90 degrees, right? Just now we saw, right? Because this angle B plus angle D should be equal to 180 degrees because it is a cyclic quadrilateral, and angle B and angle D are equal and it is a both are 90 degree. And in fact, because we have been given already that it is a rectangle, this means angle B, angle D both are 90 degrees. We need not prove it like we did in the earlier example. So it is 90 degrees. Now what we had learned was A, B, A and C. This is, ABC is an arc, right? And this, whatever angle this is subtending at the center, this will be twice of what it is subtending at the other point on the circle. So D is the other point on the circle. So angle AOC will be twice of angle ADC, right? So this will be angle AOC will be 180 degrees. It will be twice of angle D. And this was our which theorem? I think 9. The arc one was 9, I guess. Yes, this was a theorem 9. Theorem 9. So this is going to be 180 degrees. Now we have also seen that, right? It's the diameter of the circle, right, which subtends the angle 90 degrees. Or maybe we can prove it in another way also. So angle AOC is 2 into angle D, 180 degrees. And similarly, if we take BD, right? So this BD is angle BOD is equal to twice of angle C, and this is equal to again 180 degrees. So we can conclude here, that if it is subtending, this is line AC is the diameter of the circle. Why it is the diameter? Because it is the diameter of the circle which subtends a angle of 90 degree at any other point, right? We had proven that in one of the earlier questions also. See, this is the diameter of the circle. It's AB and point C is on the circumference. So this is 90 degrees. So this is the 180 degrees. So that is how We had proven that. And similarly, we can say, or maybe we should not say line, we should say here chord AC, and similarly we should say chord BD is the diameter of the circle. AC and BD intersect at O. So two diameters, when they are intersecting, diameters intersect at center of circle. So we can say that O is center of the circle. Right? There is also another method by which we can prove this, right? And that is, ABCD is a rectangle. That is something which we have been given already. And then AC and BD are diagonals of a rectangle. So diagonals of a rectangle, they bisect each other. Bisect each other. So this will mean that they are bisecting each other at. So this will mean that OA is equal to OB is equal to OC is equal to OD, right? So this point O is equidistant from O is equidistant from all the vertices of the rectangle, or maybe we can say that it is equidistant from all the 4 points. So that is why we can say O is the center of the circle, right? So we can prove it with any of the two. So we come to the next question, 16th. Consider all chords of a circle of a fixed length. What is the shape formed by the midpoints of these chords? Now, if you remember, there is a theorem which says that equal chords of a circle are equidistant from the center. Right? We learned that. So this means that suppose we take this as the center and we call it O. Call it O. Okay, so this means that if I start drawing the perpendicular from start drawing perpendicular from all these chords, from the center to all these chords, all these perpendiculars will be of the same length, right? They will all be of the same length. So what this means, and then what we are asked is, when we need to join the midpoint of all these chords, right? So One is equal chords of a circle are equidistant from the center, and before that we need to remember one more thing, because we are given that we need to find the midpoint of the we are saying, right, that what is the shape formed by midpoint of all these chords. So this means that a line joining the midpoint of the chord to the circle is perpendicular to the chord. This is also one of the theorems that we learned, right? It was the converse of theorem 5, right? That in theorem 5, we were saying that any perpendicular line, any line which is perpendicular and drawn from the center to the chord will bisect the chord. And the converse of this was that a line which is joining the midpoint to the center is perpendicular to the chord. So line joining midpoint of the chord to the circle, midpoint of the chord to the center of the circle. Center of the circle. Okay, for some reason it is coming here. So what I'll do is, yeah, it's perpendicular to the chord, and so this means all this, these are perpendicular to the chord and they are of the same length. Okay. They are all equidistant from the center. So now if we have a given point O, okay, this is the given point, and at a certain distance, at a fixed distance, if I try to, I start joining all these midpoints, what will I get? This is something that we had learned in the first video of circles when I introduced the circle chapter, right? So when I gave the definition of the circle. So definition of the circle is, from a given point, okay, if we start drawing a line which is equidistant, if we start joining all the points which are equidistant from a given point, it will form a circle, right? So this is something we had done in the first video, that from a given point, okay, in this case the given point is O, right? So from a given point, if we join, or maybe we can write in the opposite way. If we join all the points which are at the same distance, from a given point, it forms a circle. So this is by the definition of the circle, right? So we have the given point O, which was the center of our circle, and then we took all the chords which are of equal length, right? So we drew the perpendicular from these from the center of the circle to all these chords. All these perpendiculars are equal in length. Why it is equal in length? Because all the chords which are of equal length are equidistant from the center. So they are, they are of the, all the distances are same. And then we took the center and we joined all the all these midpoints which are at equal distance from the center, what will it form? It will form a circle, right? So this is the shape. So if we join all the points which are at the same distance from a given point, it forms a circle. So we can say, so if we join all the midpoints of the equal chords that are at the same distance from the center, it will form a circle. So the shape will be again a circle. So you need to actually remember all the theorems by heart. Because if you, once you know all the theorems, you remember all the theorems, you will be able to make out what we can utilize where. For example, here, because we remembered that equal chords are equidistant from the center, that is how we were able to make out that all the midpoints are equidistant from the center O. And if we are joining all these points, it will make a circle. Okay, let's see what the next question is. So the next question is, in a circle with center O, chords AB and AC are congruent. Explain why this statement is true. The center of the circle lies on the angle bisector of angle BAC. So let's start by drawing the diagram. Okay, so this is the diagram I have drawn in a circle with center O. So this is a circle with center O, right? AB and AC are congruent. These two chords are drawn which are of equal length. Okay, and then we are asked to prove that the center of the circle lies on the angle bisector of angle BAC. Okay, so what I have done here is I have drawn this line passing this AO. Okay, so okay, first I'll name this also. This is AB and maybe I'll call it M, and this I'll call N. Okay, and I'll also call this line as L. Okay, so what I'll say here is L is a line passing through O. Okay, O is the center, right? Already it is given, and I have drawn a line passing through O. I should say from A line starting at A and passing through O. Okay, I don't know whether this line is a bisector or not. Right now, we just know that this L line, it is starting from A and it is passing through O. Okay. Now, what I have done is we have been given AB is equal to AC. These two are the two chords which are equal in length. Now, we know already equal chords of a circle are equidistant from the center. This is one of the theorems, right? So this means I have drawn two perpendiculars. So OM is equal to ON. OM is the distance of the chord from the center. ON is the distance of the chord from the center to AC, right? And because these two chords are equal in length, so their distances are also equal, right? So let me now consider one more thing, because it is perpendicular drawn from the center to the chord. It is 90 degrees. And then I can say here, I can start considering the two triangles, right? I can see triangle OAM and triangle OAN. Okay. So what I see about these two triangles is, I've already said OM is ON equal to ON is equal to ON, right? Because we said this is, let's say this is 1. And here I can write from 1. What else do I know about this? OA is the common side. So OA is equal to OA, common side. And what else do I know? I know that angle OMA is equal to angle ONA is equal to 90 degrees. So let me make this. Okay, and this one. And here, so we can say right angle hypotenuse side congruency. So we see here, right? This is the right angle. OA is the hypotenuse. OM, ON are the sides, right? So hypotenuse is common anyway. It is equal. OM, ON is equal because it is both equidistant. The two chords are equidistant. And we have drawn a perpendicular bisector. So this means it is M is 90 degree, N is 90 degree, right? So these two triangles are congruent. Triangle OAM is congruent to triangle OAN. Yes, done. So now what we can say is angle OAM is equal to angle OAN, corresponding parts of congruent triangles, right? So this means what I'm saying here is this is equal to this, right? So this means line OA, or we can say, or line L is bisecting the angle BAC. We already have said that O is lying on the line L. So we can prove that, hence proved, center O lies on perpendicular bisector, not perpendicular, should say, on the bisector of angle BAC. Done? Easy? Let's move on to the next question then. Okay, so the question number 18 is, two parallel chords of lengths 10 centimeter and 24 centimeter are on the same side of the center of a circle. The distance between the chords is 7 centimeter. Find the radius of the circle. So first of all, I have drawn a circle with center O. Then I drew a chord AB of length 10 centimeter. Now I have been given that both these chords are on the same side of center. So this means that the other chord cannot be on this side, right? It has to be on this side only. So 24 centimeter is greater than 10 centimeter. The longer chords are at a lesser distance from the center. This is also we learned from one of the theorems, right? The shorter the chord, the greater the distance. Okay. So diameter is the longest chord, so it is at a zero distance from the center. So 24 is bigger, so it will be closer to the center. So that is how I have drawn CD. Okay, and they both are lie on the same side of center of the circle. So the center is O, CD is also on this side, and AB is also on the same side. Now the distance between the chords is 7 centimeter. Okay, so I have, this is, this is M and this is N. So what I have done is from O, I have drawn a line perpendicular to CD and AB. Okay, because these are parallel chords, right? So that is why I can draw a line, same perpendicular line for both CD and AB. So what happens here? This is line is intersecting CD at M. This line is intersecting AB at N. So this is the perpendicular. So this means it will bisect the chord. AN and BN will be equal. CM and DM will be equal. Okay. So now let's write down whatever we have been given. Now, so that it is clear, AB is, because in the diagram, in the question, the names are not given, right? And I have drawn this and given names so that for clarity, I will write what is what. Okay. And this is the distance MN, which is the distance between the two chords. This is 7 centimeter. Okay. Now, okay. So now we can, what else do we know? Because ON is perpendicular to AB. So, N is midpoint of the chord. You need to write the what theorem. Okay. This is a theorem specifies it, right? So it should be theorem 4, which should say this, or theorem 5, one of the two theorems, right? So then we can say that AN is equal to BN is equal to how much? 10 by 5, half of AB, right? So this will be 10 by 5 or, sorry, 10 by 2 or 5 centimeter. And what else? Similarly, we can say OM is perpendicular to CD. If it is perpendicular, so this means, so M is midpoint of CD. And what we can say in this case then? We can say that DM is equal to CM is equal to 24 by 2, or this is 12 centimeter. Okay. So now what we can do? Now we don't know, we have been asked to find out the radius. So radius here is OB, and we can also draw radius here as OD, right? So what I'll do is, first I'll take triangle. Okay, first I'll take triangle ONB. So what I'm taking is this triangle, this one, this. Okay, so I'm taking this triangle. It is a right angle triangle. So we can say here by Pythagoras theorem, OB square, which is the hypotenuse square, is equal to ON square, which is the distance square, plus BN square, which is the other side, OB square is something which we don't know, right? So ON square is something which we know half, right? We know that distance between M and N is 7 centimeter, but we don't know the distance OM, right? So I can say ON square is OM plus MN square plus BN square. Okay. Now for ease of reading, what I can say is let's assume this OM, which we don't know, is equal to X centimeter. Okay. I assume this is X and the radius OB or OD, we can call it R. Okay, this is R. So now I can write OB is R, right? So R square is equal to OM is X, MN is 7, and we are doing a square plus BN. What is BN? BN we found here, right? This is 5 centimeter. So it will be 5 square, right? Now you know the algebraic identity, A plus B. If we square it, then what do we get? A square plus B square. 7 square will be, anyways, let's expand slowly. And A square plus B square plus 2AB. So 2 into 7 into X. Or we can say it should be 14 into X plus 5 square. Or it is going to be X square plus 49 plus 14X plus 25. Okay, we don't know X here. It's okay. Let's see what we get further. Now this is for triangle ONB. Let's take the other triangle. What is the other triangle? This one, right? So this is also a right angle triangle, right? So we can do the same thing for this triangle. This triangle is OMD. So we take triangle OMD, and what we see here is by Pythagoras theorem. Now our radius here is OD. MD is, we know, right? MD or DM. This is half of 24, which is 12 centimeter. So DM is 12 centimeter. OM, we have assumed here, OM is X. OM is X. DM is 12 centimeter and OD is the radius, right? So OD is the hypotenuse here. So this OD square is equal to OM square plus DM square. Okay, so we can write OD is radius, so we can say R square is equal to, now OM square is X. We assumed here, right? Let's assume OM is X. So this is X square plus DM square we already found here. This is 12 centimeter. So this is going to be 12 square. Then we can write this as X square plus 144, right? So we can call this as 1, and we can say this is 2, so that we can refer to them. Okay. Now we can see 1 and 2 are equal because both are equal to R square, right? R square. So this means we can write X square plus 49 plus 14X plus 25 is equal to X square plus 144. Bring the like terms together. X square We'll bring this right side x square to left. So again it is x square. Now numbers will bring to the right side. So we will have 14x here left. And then all the numbers we will bring to this side. 144, bring the 49 this side. So minus 49 and minus 25. So now what we get? X square minus x square is 0. We are left with 14x. And here we have 144 minus what? 9 minus 5 is 4 and 4 minus 9 5 is 14 because both are negative, right? So they'll be added. 9 5 14 1 4 1 5 6 7. So this is right. What I did was add 49 and 25 because this is going to be minus 49 plus 25, right? So 49 plus 25 is 74. So this is going to be minus 74. So 144 minus 74 is going to be equal to 70. So x will be 70 divided by 14, which is equal to 5. So x is 5 centimeter. What is x? OM, right? We know OM, we know DM, we can calculate OD, right? So what we do is putting the value of x in to what we'll get. This is the equation 2. What we are getting, r square is equal to x square, which means 5 square plus 144. This is equal to 25 plus 144, which is equal to 169. And you know, right? We have seen in so many questions now. What is the square root of 169? 13. 13 into 13 is 169. So few of the Pythagoras triplets you should, by now you have done so many questions. So you should actually remember also few of them, right? So this 5, 12, 13, this is one such, triplet. 3, 4, 5 is the most common and easiest one to remember. So 3, 4, 5 is 1. 5, 12, 13 is 1. Then I think there is one with 8, 12, 13 also. 8, 12, 13 or 8. So 8, 8, 64. And I think, yeah, something of that sort is also there. Okay, so this is given us the answer. Radius is 13 centimeter. Find the radius of the circle. So with that, we are done with this question number 18. I'll continue with the further questions. I think 19, 20, 20. We are left with 19 to 26. So I'll see how much we can cover in the next two. I think it will take 2 more videos to cover. Then we'll be done with this end of chapter exercises for radius is for circles. And then we'll move on to the area and perimeter, the end of chapter exercises. Already all the concepts I have covered in my videos. Please watch that if you have not already. Okay, till then, bye-bye.